Registered Master Plumbing Engineers of the Philippines Review. Quiz number 7, 2025. Number 1. The minimum distance between a cesspool and a water supply line, as noted in Table 7, is blank. A. 100 feet. B. 20 feet. C. Not recommended as a substitute for a septic tank. D. 15 feet. The correct answer is option C is a factual statement often found in codebooks regarding cesspools, that they are not recommended as substitutes for septic tanks. White heavy checkmark explanation, based on standard plumbing and sanitation codes. According to Table 7 of the National Plumbing Code of the Philippines, NPCP, which specifies minimum separation distances between sanitary fixtures and water sources. The minimum horizontal distance between a cesspool and a water supply line is 15 feet, approximately 4.5 meters. This distance helps prevent contamination of the potable water supply due to seepage or leakage from the cesspool. Pushpin note: while a septic tank is preferred, a cesspool may still be allowed in certain areas, but only if it complies with minimum setback requirements. Number 2. Who originally proposed using drainage fixture units to represent a fixture's load-producing effect on the plumbing system? A. Wyly and Eaton. B. Roy B. Hunter. C. H. Manning. D. F. M. Dawson. The correct answer is B. Roy B. Hunter. White heavy checkmark explanation. The concept of drainage fixture units, DFUs, was developed by Roy B. Hunter in the 1920s-1940s while working for the National Bureau of Standards, now NIST. Hunter introduced the probabilistic method for estimating plumbing system loads, recognizing that not all fixtures operate simultaneously. He created the fixture unit system to quantify the hydraulic load of each plumbing fixture based on O flow rate, O duration of use, and O frequency of use. This system is the foundation of modern plumbing design in codes like the IPC, International Plumbing Code, and NPCP, National Plumbing Code of the Philippines. Blue Book, his landmark paper, Modern Plumbing Practice Based on the Theory of Probability, 1940, revolutionized plumbing engineering. Why not the others? A. Wyly and Eaton contributed to water supply fixture unit research, but not drainage. C. H. Manning, known for Manning's equation in open channel flow, not fixture units. D. F. M. Dawson, not associated with the origin of DFUs. White heavy checkmark. Final answer, B. Roy B. Hunter. Number 3. The first step in the design of a subsurface soil absorption sewage disposal system is A. Ascertain the code requirements. B. Determine whether the soil is suitable for the absorption of the septic effluent. C. Determine the area required for the disposal field. D. Calculate the fixture unit load to be served. The correct answer is B. Determine whether the soil is suitable for the absorption of the septic effluent. White heavy checkmark explanation. In the design of a subsurface soil absorption system, also known as a leach field or drain field, the very first and most critical step is to evaluate the soil's ability to absorb and treat septic tank effluent. This is typically done through percolation, perk, test soil borings or deep observation pits assessing soil texture, structure, depth to groundwater, and seasonal high water table. Pushpin Y. Even if the fixture load is calculated or code requirements are known, the system cannot function if the soil is unsuitable, example, clay with poor percolation, bedrock, or high water table. The entire design depends on soil permeability. Only after confirming soil suitability do you proceed to calculate fixture unit load, D, determine required absorption area, C, verify against local code requirements, A, code reference, International Private Sewage Disposal Code, IPSDC, and National Plumbing Code of the Philippines, NPCP. Both require site and soil evaluation as the initial step in on-site sewage system design. White heavy checkmark. Final answer, B. Determine whether the soil is suitable for the absorption of the septic effluent. Number 4. What is the recommended drainage fixture unit load for a single lavatory? A1, B3, C2, D4. The correct answer is A1. White heavy checkmark explanation. According to standard plumbing codes, including the International Plumbing Code, IPC, and the National Plumbing Code of the Philippines, NPCP, the drainage fixture unit, DFU, value assigned to a single lavatory, wash basin, is 1 DFU. This value represents the hydraulic load, based on flow rate, duration, and frequency of use, that a lavatory contributes to the drainage system. Reference, IPC Table 709.1 NPCP Table 7.1. Fixture. DFU, private use. Lavatory, basin. 1. Water closet, flush tank. 4. Shower. 2. Kitchen sink. 2. Electric light bulb. Note, DFU values may differ slightly for public versus private use, but for a standard residential lavatory, 1 DFU is universally accepted. White heavy checkmark. Final answer, A1. Number 5. What approximate percentage of new home construction employs a septic tank soil absorption sewage disposal system? A. 15%. B. 30%. C. 25%. D. 20%. The correct answer is C. 25%. White heavy checkmark explanation. According to data from the U.S. Census Bureau and the Environmental Protection Agency, EPA, approximately 25% of new home constructions in the United States rely on on-site sewage disposal systems, primarily septic tank and soil absorption, drainfield, systems. Bar chart. This percentage is consistent across multiple sources, including Times US EPA, about 25% of U.S. households use septic systems. Times U.S. Census Bureau's survey of construction, roughly 1 in 4 new homes, especially in rural and suburban areas not served by municipal SORs, are built with septic systems. While the exact figure can vary slightly by year and region, 25% is the most widely accepted and cited approximation in plumbing engineering references and textbooks. Why not the others? A. 15%, too low, outdated or underestimates rural construction. B. 30%, slightly high for new construction, though overall existing homes on septic may approach 30%. D. 20%, close, but 25% is the standard figure used in plumbing exam references. White heavy checkmark. Final answer, C. 25%. Number 6. The drain lines for distributing the effluent from the septic tank should be spaced no greater than blank apart. A. 12 feet. B. 6 feet. C. 9 feet. D. 3 feet. The correct answer is B. 6 feet. White heavy checkmark explanation. In a subsurface soil absorption system, leach field or drain field, the lateral drain lines, also called distribution trenches or perforated pipes, must be spaced properly to ensure effective effluent dispersal and adequate soil treatment. According to standard plumbing and environmental health guidelines, including the National Plumbing Code of the Philippines, NPCP, and US EPA design manuals, drain lines should be spaced no greater than 6 feet, center to center. This spacing prevents overloading of the soil in one area, allows uniform percolation, provides sufficient undisturbed soil between trenches for microbial treatment and aeration. Straight ruler typical trench width, 18 to 36 inches. Straight ruler center-to-center spacing, maximum 6 feet. Why not the others? A. 12 feet, too wide, reduces treatment efficiency. C. 9 feet, exceeds standard maximum. D. 3 feet, acceptable, closer spacing is allowed, but not the maximum. The question asks for no greater than, so the maximum allowable is 6 feet. White heavy checkmark. Final answer, B. 6 feet. Number 7. The generally accepted pressure in a sanitary drainage system is blank. A. plus or minus 1 inch of water column. B. plus or minus 10 inches of water column. C. plus or minus 100 inches of water column. D. plus or minus 0.1 inch of water column. The correct answer is A. plus or minus 1 inch of water column. White heavy checkmark explanation. In a sanitary drainage and vent system, the primary purpose of vent piping is to maintain air pressure equilibrium and prevent trap seal loss. According to plumbing engineering standards and references, including Roy B. Hunter's research and modern plumbing codes. The generally accepted maximum pressure fluctuation allowed in a sanitary drainage system is plus or minus 1 inch of water column, in WC. Trap seals, typically 2 inches deep, can be partially or fully lost if pressure deviations exceed this limit. A plus or minus 1 inch. WC variation is considered safe to maintain trap integrity and prevent sour gases from entering the building. Warning sign if pressure exceeds plus or minus 1 inch. WC, siphonage or blowout of trap seals can occur. Why not the others? B plus or minus 10 inches. WC far too high, would easily break trap seals. C plus or minus 100 inches. WC equivalent to ~3.6 psi, catastrophic for drainage systems. D plus or minus 0.1 inches. WC overly restrictive, not the accepted practical limit. White heavy checkmark. Final answer, A plus or minus 1 inch of water column. Number 8. The quantity of sewage flow from a single family dwelling per person is _______________ gallons per day. A 100. B 150. C 50. D 75. According to common plumbing standards, including the International Plumbing Code and various regional master plumbing guidelines, the estimated sewage flow for a single-family dwelling is typically calculated at 75 gallons per day, GPD, per person. Answer, D 75. Quick breakdown of common estimates. Times 50 to 75 GPD, standard range used for residential design calculations. Times 100 GPD, often used as a conservative peak estimate or for luxury homes with higher water usage. Times 75 GPD, the most frequent value cited in board exam reviewers for registered master plumbers in the Philippines. Answer key summary, including your previous questions. If you are compiling these for your quiz number 6, 2025 reviewer, here is the updated list. No. Question topic. Correct answer. 21. Sewage flow per person, residential. D 75 gallons. 22. Minute distance, cesspool to water line. 10 feet, standard table 7. Note on question 22, from your previous prompt in most standardized tables, the distance from a cesspool to a water supply line is 10 feet. If 10 feet was not an option in your specific source, please check if the question refers to the distance to a public water main, which is often 50 feet, or a water well, which is 100 feet. Number 9. Which common formula for calculating flow in pipes is meant for open channel flow? A. Manning. B. Darcy-Weisbach. C. Shea. D. Hazen and Williams. The correct answer is A. Manning. White heavy checkmark explanation. The Manning formula is the most commonly used equation for calculating flow in open channel systems, such as SORS, flowing partially full, drainage ditches, stormwater channels, rivers. It is specifically designed for gravity-driven flow where the fluid surface is exposed to the atmosphere, i.e., not under pressure. Blue Book Manning's equation. Q equals 1.486 nar 23 s 12, where times Q equals flow rate, feet cubed s, times N equals Manning's roughness coefficient, times A equals cross-sectional area of flow, times R equals hydraulic radius, times S equals slope of the energy grade line, bed slope for uniform flow. This formula is widely used in sanitary and storm sewer design, especially in plumbing and civil engineering practice in the Philippines and under IPC standards. Why not the others? B. Darcy-Weisbach, used for pressurized, closed conduit, flow, accounts for friction losses in full pipes. C. Shea, an older open channel formula, but less commonly used today than Manning's. Manning is actually a refinement of Shea's equation. D. Hazen Williams, used exclusively for pressurized water flow in pipes, example, water supply systems, not sewage or open channels. Electric light bulb. While Shea is also for open channel flow, the question asks for the most common formula, and Manning is the standard in modern plumbing, civil, and sanitary engineering. White heavy checkmark final answer, A. Manning. Number 10. The primary purpose of a septic tank is to blank. A. Chemically treat raw sewage. B. Distribute raw sewage to the leaching field. C. Act as a settling tank. D. Vent odors to atmosphere. The correct answer is C. Act as a settling tank. White heavy checkmark explanation. The primary purpose of a septic tank is to separate solids from liquids in raw sewage through physical settling and flotation, making it function as a primary settling, sedimentation, tank. Here's what happens inside. Solids settle to the bottom forming sludge, grease and oils float to the top forming scum. The partially clarified liquid, effluent, in the middle flows out to the soil absorption system, leach field. Microscope. While some anaerobic digestion occurs, biological breakdown, the septic tank is not designed for full chemical or biological treatment that occurs in the drainfield soil. Thus, its main function is settling and retention, not treatment, distribution, or venting. Why not the others? A. Chemically treat raw sewage. Incorrect. Septic tanks provide limited biological degradation, not chemical treatment. B. Distribute raw sewage to the leaching field. No. It pre-treats sewage first. Only clarified effluent, not raw sewage, goes to the leach field. D. Vent odors to atmosphere. Venting occurs via the plumbing vent system, not the septic tank's primary purpose. White heavy checkmark final answer, C. Act as a settling tank. Number 11. The recommended septic tank capacity for a 5-bedroom home is blank. A. 1,000. B. 750. C. 1,250. D. 900. The correct answer is C. 1,250. White heavy checkmark explanation. According to standard plumbing and sanitation guidelines including the National Plumbing Code of the Philippines, NPCP, International Private Sewage Disposal Code, IPSDC, and Common Engineering Practice, the minimum recommended septic tank capacity is based on the number of bedrooms, which is used as a proxy for expected occupancy and wastewater flow. Standard sizing, NPCP IPC guidance 1 to 2 bedrooms, 1,000 gallons 3 bedrooms, 1,000 gallons 4 bedrooms, 1,200 gallons 5 bedrooms, 1,250 gallons add 250 gallons per additional bedroom beyond 5. Electric light bulb. The 1,250 gallon capacity ensures adequate retention time, typically 24 to 48 hours, for solids to settle and begin anaerobic digestion before effluent flows to the drain field. This value is widely accepted in Philippine Plumbing Board exams and design standards. Why not the others? A. 1,000 suitable for up to 3 to 4 bedrooms, but insufficient for 5. B. 752 small, below minimum for even a 2-bedroom home. D. 900 not a standard size, still too small for 5 bedrooms. White heavy checkmark final answer, C. 1,250. Number 12. The absorption area to be provided for an individual residence containing 3 bedrooms with a percolation rate of 3 minutes is recommended to be blank. A. 300 square feet. B. 400 square feet. C. 200 square feet. D. 100 square feet. The correct answer is A. 300 square feet. White heavy checkmark explanation. To determine the required absorption area, leach field size, we use the percolation rate, perk rate, and standard design tables from plumbing codes like the National Plumbing Code of the Philippines, NPCP, or International Private Sewage Disposal Code, IPSDC. Step 1. Determine sewage flow. For residential design, sewage flow is based on number of bedrooms. Standard assumption, 120 gallons per day, GPD, per bedroom. 3 bedrooms times 120 GPD equals 360 GPD. Note, some codes use 100 to 120 GPD bedroom. NPCP often uses 120 GPD for this calculation. Step 2. Use percolation rate to find absorption rate. Percolation rate equals 3 minutes per inch. From NPCP Table 7.5, or similar standards, A 3-minute perk rate corresponds to an absorption capacity of about 1.2 gallons per day per square foot, GPD square feet. Pushpin common NPCP absorption rates. 1 to 5 minute inch 1.2 GPD feet squared. 6 to 7 minute inch 1.0 GPD feet squared. 8 to 10 minute inch 0.9 GPD feet squared, etc. Step 3. Calculate required absorption area. Area equals daily sewage flow absorption rate equals 360 GPD 1.2 GPD feet, 2 equals 300 feet 2. White heavy checkmark. This matches option A. Why not the others? B. 400 square feet would apply for slower perk rates, e.g., 5 to 6 minute inch. C. 200 square feet too small, would require a very fast perk rate, less than 1 minute per inch, which is rare. D. 100 square feet far too small, violates code minimums. White heavy checkmark. Final answer, A. 300 square feet. Number 13. What is the maximum length of a pipe having threads on both ends such that it can be called a nipple? A. 8 inches. B. 15 inches. C. 12 inches. D. 10 inches. The correct answer is C. 12 inches. White heavy checkmark. Explanation. In plumbing and piping terminology, a nipple is a short piece of pipe that has male threads on both ends and is used to connect two fittings. According to standard plumbing references, including National Plumbing Code of the Philippines, NPCP, ASME-B 16.11, forged fittings, industry practice, e.g., Ferguson, Charlotte pipe, etc. A nipple is defined as a threaded pipe 12 inches 300 millimeters. Pipes longer than 12 inches with threads on both ends are typically called threaded pipe sections or close nipples only if very short, example, 1 to 3 inches. Standard nipples come in lengths from half an inch up to 12 inches. Beyond 12 inches, it's no longer classified as a nipple in standard trade and code usage. Electric light bulb note: close nipple equals no unthreaded portion, standard nipple equals threaded ends with some unthreaded middle, up to 12. Why not the others? A. 8 inches, within nipple range, but not the maximum. B. 15 inches, exceeds standard definition. D. 10 inches, still a nipple, but again, 12 inches is the accepted maximum. White heavy checkmark. Final answer, C. 12 inches. Number 14. Sewage pit connecting piping blank. A. Must be 6 inches in diameter minimum. B. Should be laid at a minimum grade of 2%. C. Must be at least 5 feet deep. D. None of these. The correct option is B. Should be laid at a minimum grade of 2%. Explanation. Times sewage pit connecting piping, or similar horizontal drainage piping, must be installed with a minimum slope, grade, of 2%, or a quarter inch per foot, to ensure proper flow and prevent clogs. This standard is widely adopted in plumbing codes. Why other options are incorrect? Times A must be 6 inches in diameter minimum. While some main saws may have a minimum diameter of 8 inches, building saws and connecting pipes can be smaller, example, 4 inches for a water closet. A 6-inch minimum is not universally required for all connecting piping. Times C must be at least 5 feet deep. The depth of a saw pipe installation depends on factors like frost lines, ground conditions, and local regulations, and is not a universal minimum of 5 feet for all connecting pipes. Times D. None of these. Since option B is correct based on standard plumbing practices and codes, this option is incorrect. Number 15. If a small amount of pipe exists between the threads of a pipe, it is called a short nipple. Its other name is A. Coupling, B. Close nipple, C. Pipette, D. Shoulder. The correct option is D. Shoulder. Explanation. A shoulder with no unthreaded pipe, or only a very small amount, between the threads, such that when two female fittings are screwed tightly onto it, very little of the nipple remains exposed, is called a shoulder, also known as a running nipple. Number 16. A covered pit with an open-jointed or perforated lining into which raw sewage is discharged is called a A septic tank. B none of these. C cesspool. D seepage pit. The correct answer is C cesspool. White heavy checkmark explanation. A cesspool is defined as a covered, underground pit with perforated or open-jointed walls, often made of concrete blocks, brick, or tile, that allows raw sewage to seep directly into the surrounding soil. Unlike a septic tank, a cesspool does not separate solids and liquids, it discharges untreated sewage into the ground. It lacks a separate soil absorption, leach field. The pit itself acts as both tank and absorber. Due to environmental and health concerns, cesspools are prohibited in many areas. But they are still referenced in plumbing codes, example, NPCP, with strict location and construction rules. Why not the others? A septic tank has watertight walls, retains solids, and discharges only clarified effluent to a drain field. Not perforated. D seepage pit typically receives pre-treated effluent, e.g., from a septic tank, not raw sewage. It's a type of absorption pit, not a disposal pit. B, none of these incorrect, because C is correct. White heavy checkmark final answer, C. Cesspool. Number 17. The retention period of sewage in a septic tank should be blank. A 12 hours. B 36 hours. C 6 hours. D 24 hours. The correct answer is D 24 hours. White heavy checkmark explanation. The retention time, or detention time, in a septic tank is the amount of time raw sewage remains inside the tank to allow solids to settle, forming sludge, scum to float, partial anaerobic digestion to occur. According to standard plumbing and sanitation guidelines, including the *** National Plumbing Code of the Philippines, NPCP, and US EPA recommendations, the minimum recommended retention time in a septic tank is 24 hours. This ensures adequate separation of solids and liquids before the effluent flows to the soil. Absorption system. Pushpin NPCP section 1404.2 and similar codes base septic tank sizing on a 24-hour retention period using peak daily flow, example, 120 gallons per bedroom times 24 hours. Why not the others? A 12 hours too short, insufficient. For proper settling. B 36 hours longer than required. Not the standard design basis. C 6 hours far too short, would result in solids entering the drain field, causing failure. White heavy checkmark final answer, D 24 hours. Number 18. A vertical pipe that carries away clear water waste from equipment and non-sanitary fixtures is called a blank. A soil stack. B water stack. C sanitary stack. D waste stack. The correct answer is D waste stack. White heavy checkmark explanation. In plumbing terminology, a waste stack is a vertical pipe that carries clear water waste, also called grey water, from non-sanitary fixtures such as sinks, lavatories, kitchen, showers, washing machines, equipment drains, e.g., air conditioner condensate, floor drains in non-toilet areas. Droplet this water does not contain human waste, i.e., no discharge from water closets or urinals. In contrast, a soil stack carries sanitary waste, from water closets and urinals. A sanitary stack is a general term that may combine both soil and waste, but typically implies it carries soil, black water. Water stack is not a standard plumbing term. According to the National Plumbing Code of the Philippines, NPCP, and International Plumbing Code, IPC, times waste pipe stack conveys only liquid waste, no fecal matter. Times soil pipe stack conveys fecal-containing waste. Thus, a vertical pipe for clear water waste is specifically called a waste stack. White heavy checkmark. Final answer, D. Waste stack. Number 19. A Y fitting has a catalogue designation of 4x3x1t. What does the second number, 3, indicate? A. Size of branch. B. Upstream size of main. C. Number of threads. D. Downstream size of main. The correct option is D. Downstream size of main. Explanation. In plumbing catalogue designations for a Y or T fitting, the sizes are typically given in the order of the main pipe's upstream size, the main pipe's downstream size, and then the branch size. For a designation like 4x3x1t, the second number, 3, indicates the downstream size of main. Why other options are incorrect? Times A. Size of branch is incorrect because the branch size is indicated by the third number, which is 1 in this example. Times B. Upstream size of main is incorrect because the upstream size of the main is indicated by the first number, which is 4. Times C. Number of threads is incorrect because the numbers refer to the nominal pipe sizes, diameters, in inches, not the number of threads. Thank you for watching. That concludes our Registered Master Plumbing Engineers Review, quiz number 7. How many did you get right? Let us know your score in the comments below. If you found this quiz helpful for your 2025 board exam preparation, please give this video a thumbs up and subscribe to Engel Tutorial for more high-yield plumbing engineering content. Keep grinding, future master plumbing engineers. Success is just one review away.